welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on the topic acid, base, and salts. And our subtopic for today is water hardness. So we're going to be discussing on the ways to remove water hardness. So in the previous lesson, we looked at the type of water hardness that exists. So today we are going to look at how can we remove this water hardness, and then you do a few questions. So there are different ways of removing temporary water hardness, and one of them is boiling. We mentioned about boiling previously in the previous lesson, just a little bit of it. We mentioned about the presence of the hydrogen carbonate ions, which causes the temporary hardness, but the cations can either be calcium ions or magnesium ions. So when we boil water, for example, we have calcium hydrogen carbonate or magnesium hydrogen carbonate, it usually decomposes. When it decomposes, it forms the insoluble salts of calcium carbonate and magnesium carbonate, which is deposited on the sides of the vessel. So if you had like that kind of water, you notice some white substances on the sides of the vessel. So this forms an incrustation commonly known as far, and the process being firing. So you can see the equation calcium hydrogen carbonate. When you decompose it, you form calcium carbonate, carbon dioxide, and water. This is a reaction we did in action of heat on hydrogen carbonate as we were discussing salts. And when you heat magnesium hydrogen carbonate, you see it forms magnesium carbonate, carbon dioxide, and water. Another method of removing temporary hardness is by addition of calcium hydroxide, also known as lime water. So what happens when you add calcium hydroxide? There's a precipitation reaction that occurs. This method is usually very cheap, and it is the one that is used for large scale treatment in water treatment plants. It's very cheap because of the availability of the lime water. So if excess lime ions are added, it will make the water hard again. So even if it's that cheap and like very available water treatment method, it needs to be controlled. So this is the equation. As you can see, calcium hydrogen carbonate reacts with calcium hydroxide to form calcium carbonate and water. And remember, this is now the FAR as we measured in the previous method. Another method is addition of ammonia solution. So if aqueous ammonia solution is added to water containing calcium and magnesium hydrogen carbonate, precipitates of calcium and magnesium ions as corresponding carbonates are formed. So when we add ammonium hydroxide to calcium hydrogen carbonate, we form calcium carbonate, water, and ammonium carbonate. So the same thing happens with the magnesium hydrogen carbonate. You form ammonium carbonate, magnesium carbonate, and water. So you notice there are some methods that both applies to temporary and hard water, permanent and temporary, sorry. So you notice like boiling. Boiling is not a method you can use in permanent hardness, but you can use the addition of ammonia in permanent hardness, as you see some of the other processes. So one of the processes that can be used both in temporary hardness and um, permanent hardness, you notice is distillation. So distillation, it means that water that is containing dissolved salt is heated. When it's heated, it means the water will evaporate fast, and then it's going to cool down, as you can see in the evaporating setup, and then the dissolved salts are left in the flask. It is less in economic value, and it is too expensive because you see you're using a lot of energy. There needs to be a heating system and also a cooling system. So sometimes it can use a lot of energy. That is why it is expensive. It's not that commonly used for large scale purposes, but in small scale it can be used. Another method that can be used both on temporary hardness and permanent is the permitute method or the ion exchange method. This method is usually used for as uses a complex sodium salt. We usually call it sodium X because the X can change. So the sodium aluminum silicate, or commonly known as sodium permitute. So it has sodium ions in the permitute, as you can see in the setup shown. So what happens, it's usually manufactured ion exchange resin. So materials that will take ions from one element out of its compound and replace it with ions with another element. That is what we refer to as exchange. They're exchanging the ions. So you notice the ions in the permitute are sodium ions, but the ions in the hard water are calcium ions and magnesium ions. So what it does, there is an interchange of those ions. So the interchange now is what we call the ion exchange. So how does it work? So the permitute is a contained in a, the permitute is contained in a metal cylinder, or the sodium aluminum silicate is contained in a metal cylinder, as you can see in the image. And then the hard water is passed through the column. So we put hard water at the top in the column of the permitute in the cylinder, and it emerges as soft water at the other end. So what happens in between is that hard water, as it passes through the ion exchange, uh, as in the permitute or in the column, ion exchange takes place. So the calcium ions and magnesium ions in the hard water are interchanged with sodium ions, as you can see. So we usually have this sample of equation. So if we had sodium X or sodium aluminum silicate to react with calcium ions, you see there's an interchange of cations. So we form calcium aluminum silicate, and sodium ions are discharged off as as like interchanged. So this is what the sodium ions are, the ones that pass in the soft water, and then the calcium X is left in the in the column. So the sodium ions are the ones that are passing, and then the magnesium and calcium ions are left behind. So when all the sodium ions in the permitute have been replaced by calcium and magnesium ions, the permitute must not go on softening the water. So it is usually regenerated using brine. This is concentrated sodium chloride, so which all the calcium and magnesium chloride are washed away. So it has to keep on being regenerated because it can't be used continuously for a long time because of the excessive calcium and magnesium ions on the permitute or in the column. So it needs to be replaced, and it is replaced by using concentrated sodium chloride solution. So this is regeneration. This is how it happens. So we have the calcium X or magnesium X in the permitute. So if sodium chloride is added or the brine is added, there's the exchange that happens to form calcium chloride and magnesium chloride, and then the permitute is regenerated. So calcium chloride and magnesium chloride is washed away, and we are left with our permitute as it was earlier on. So we also have another method called deionization or demineralization. So deionization is an advanced ion exchange method for producing deionized water. So deionized water is extremely pure water made of only hydrogen and oxygen only, without any dissolved substances, as you can see in the setup. So deionization involves using the resins that remove all the cations by using either a cation exchanger. So we have in the deionization method, we have the cation exchanger, which removes or absorbs all the cation present in water and leaves only hydrogen ions. So you can see in the first part of the setup, we have the water coming in the first ion exchange, where now all the cations are removed. You can see the water, the sodium ions, calcium cations, they're all replaced, and it's just left with hydrogen ions in the water. And then there is now the remaining water passes through the anion exchanger. This is now where it removes all the dissolved anions that can be sulfate, chloride in the case of permanent hardness, and the hydrogen carbonate ions in the case of temporary, and they are replaced with hydroxyl ions or H ions. So the hydrogen ions and OH ions neutralize each other to form pure water. And when the cation exchanger is exhausted, it is regenerated by adding sulfuric acid or hydrochloric acid, as you can see on the side in the setup. And when the anion exchanger is exhausted, it's regenerated by adding sodium hydroxide, as you can see in the setup. So, removing permanent hardness, you said you can also use a washing soda, which is sodium carbonate. So washing soda softens hard water by causing the formation of a carbonate insoluble salt. So the soluble sodium salts left in water do not react with soap. So if you react sodium carbonate with calcium chloride, there is an interchange of cations. It's like double decomposition, and you can see we form an insoluble calcium carbonate. So that's it shows even ionically what happened. And then also sodium carbonate can react with magnesium sulfate. Remember, we are removing the chloride ions and sulfate ions, so there is still an interchange of cations. So this method is usually convenient and economic in large scale. It's because it softens both temporary and permanent hardness. So after that, you look at some advantages of hard water. They're usually good for drinking purposes because it has calcium ions, which helps with strong bones and teeth. And then when soft water flows in lead pipes, some lead is dissolved, hence lead poisoning. But when lead dissolves in hard water, it forms lead carbonate, which coats the inside of the lead pipes, preventing any further reaction. So this reduces any chances of lead poisoning. So you can see where the hard water comes in handy, especially in preventing lead poisoning on lead pipes. It's also good for brewing and tanning industries because it gives the beer a flavor. Some of the disadvantages of hard water is that it forms insoluble salt with magnesium and calcium ions. That is the scum, which we call the magnesium stearate or calcium stearate. So it wastes a lot of water. So for this reason, soapless detergents are preferred for ordinary soap because they do not form scum but rather form soluble salts. So soluble salts of the sulfates and chlorides. So detergents, examples of detergents, soapless detergent are like the powder detergents like Omo, Perfect, Persil, Fab, whichever. And then the composition of insoluble magnesium and calcium carbonate and sulfate from hard water cause the blockage of water pipes because of the scales that form. And then also the fire which forms can also coat electrical appliances and causing them not to be efficient. There's also formation of scum on clothing, which reduces durability and aesthetic appearances. So marks are left on, like if it's white clothes, you can see those marks being left behind. So let's look at this question. So the column below is used to soften hard water. So we have the hard water passing through the ion exchange containing sodium ions, and then soft water passes through. Explain how the hard water was softened as it passes through the column. So if we were to explain, we will say the calcium ions and magnesium ions in the hard water are exchanged with sodium ions in the column, forming calcium X and magnesium X, one sodium ions passes in the water, causing it to be soft. And then after some time, the material in the column is not able to soften add water, or is the material reactivated? We said by passing concentrated brine or just brine or concentrated sodium chloride, which causes the formation of and calcium chloride and magnesium chloride that is collected. That's it. That brings us to the end of the session. So see you in the next lesson.